Welcome, ladies and gentlemen. So what I'd like to do is show you how to multiply binomials now with higher order binomials. So we previously did one where we're just multiplying binomials, but now we're gonna work on multiplying them with higher order. Now we've already kind of gone over how to multiply monomials. Remember, you can only multiply when the bases and the bases are exactly the same, and when you have, like, for instance, x to the a times x to the b, then that equals x to the a plus b. And if you have c x to the a times d x to the b, therefore you're going to multiply the coefficients, c times d, and then add the powers. Okay? So just kind of some rules, but that's kind of the kind of confusing things, but that applies for every single one of these problems. Now again, there's multiple techniques that we use to multiply binomials, even if they're higher order. We can look at distributive property, we can look at FOIL, or we can use the box method. And I like all four methods. I usually typically use the distributive property one, and then when things kind of get a little bit messy, I like to use the box method. But I'll just kind of go through each method here. So the first one is the distributive property. If you remember the distributive property, a times b plus c, basically tell us you need to multiply a times b and a times c. Okay? And that's going to be true. It doesn't matter how many terms are on the outside or on the inside of your parentheses. So in this case, I need to multiply 3 times x squared and 3 times 2. So I'm just going to do 3x squared. 3 times x squared is 3x squared. 3 times 2 is positive 6. And then I'm going to do an x squared times x squared and x squared times 2. So x squared times x squared is going to be a x to the 4th. And x squared times 2 is going to be a positive 2x squared. Now basically what I'm doing is looking for terms that are going to be common, that have the exact same base as well as power. And because you can only combine terms that are exact same exponent, same base and same power, and that's going to be my x squared. And then I'll rewrite everything in descending order. So my first highest power is going to be 4. And then I'll have 3x squared plus 2x squared is going to be 5x squared, and then plus 6. The next method we can work on is using FOIL. And FOIL, again, represents first, outer, inner, last. So the first two terms we'll label with an F. The outer terms are your outer two terms from your parentheses. Then you have your inner terms. And then you have your last terms. And basically, you're just multiplying them. It's the same thing as distributive property. It's just a nice way to kind of remember things. So multiply my first two terms is going to be x squared times x squared. Multiply my outer terms is going to be x squared times negative x. Multiply my inner terms is 2x times x squared. And multiply my last term is 2x times negative x. Now I can simplify that to x to the 4th negative x cubed equals, let's see, that's going to be positive 2x cubed. And this will be a negative 2x squared. You notice that these two terms have the same base, x, and the same power, so I can combine them. And therefore, I'll just write this as x to the 4th. Negative x cubed plus 2x cubed is going to be a positive x cubed, and then minus 2x squared. The last thing that we can do to multiply is think of them as a product. You could think of this as a length times a width, and length times width is going to represent the area of a rectangle. So what we'll do is we'll just create a nice little box, and then for each term we're going to make a divider. So therefore I'll put one product on one side, so I'll do 4x to the 5th minus 2x to the 4th, and then I'll do 2x cubed over here and negative 3x squared over here. Because basically when you're multiplying two binomials or the product of two numbers at all, you're finding the area. So basically what we're doing here is finding the area of this box. Now again, now that since there's for two terms, I've segmented this. So now all we're really doing is just finding the area. 4x to the 5th times 2x to the 3rd is giving you the area of this little box here. So therefore, this becomes 8x to the 8th. 2 times 4 is 8. X cubed times x to the 5th is x to the 8th. 2 times negative 2 is negative 4. X to the 7th, as I add the powers, remember. Negative 3 times 4 is a negative 12, x to the 7th. And then over here, I get a positive 6, x to the 6th, as I add the powers. Actually, I do have two common terms, don't I? I have common terms here on my diagonal. They both have a variable x, and they're raised to the 7th power. So now I just write it in descending order. So I use my highest degree first, so that's 8x to the 8th. And negative 12x to the 7th minus 4x to the 7th is a negative 16x to the 7th. And then plus 6x to the 6th power. Okay? Last but not least, let's go and do our last example. Again, I'll just use the box method. I like the box method. It organizes everything. Minus 4x, and this one's x squared plus 1. So therefore, I'm just going to kind of work through this. 3x cubed times x squared is going to be 3x to the 5th. X squared times negative 4 is a negative 4x cubed. 3x cubed times 1 is a 3x cubed. And negative 4 times 1 is a negative 4x. Again, middle terms are like terms, so I can combine them. So my final answer is 3x to the 5th minus x cubed minus 4x. And there you go, ladies and gentlemen. That is how you multiply binomials to higher powers. Thanks.